Students, in the lecture one, we have learned few things and few terminologies of science and chemistry. So study of nature is science. Okay, in the previous class we have learned study of nature is science. Science has many branches. In those, chemistry is one of the important branches, and chemistry deals with the matter. Matter is composed of molecules, and molecules are composed of atoms. Okay, and the atom has three fundamental particles: proton, represented by P, electron, E, neutron, N. So simply PEN, right? So this is what we have learned in the previous class. Now let us see the properties of proton, electron, and neutron. Proton, electron, and neutron, right? Right. Now you see, let us learn the remaining. So here, proton. It is a positively charged particle. It is a positively charged particle. Positively charged particle. Proton is a positively charged particle, and it is represented by a letter P. Letter P. So as you know that there are two types of charges, positive charge and negative charge. Here proton has positive charge. Now coming to electron, it is represented by a letter E, or E minus. This is minus charge. So it is a negatively charged particle. Negatively charged particle. So that is why it is represented with E minus. There is no positive charge on the proton. So simply P. P is always positive. Electron negative. So electron is a negatively charged particle. Now coming to neutron, this is a third subatomic particle represented by letter N. Okay, it is a neutrally charged particle. It is neutrally charged. Neutrally charged particle. Neutrally charged particle means no charge. Neutrally charged particle means no charge. Okay. So here three fundamental particles: proton, electron, neutron. Proton with positive charge, electron with negative charge, neutron with no charge. Okay, that is zero, no charge, neither positive nor negative. That is no charge, right? Now let us see, okay, the structure of atom. The structure of atom. Okay, atom is spherical in shape. Spherical in shape. In general, it is spherical in shape. In general, it is spherical in shape. Right? Now let us understand the location of these three fundamental particles. That means where are these in atom? Okay. So here it is the atom. This is the atom. And it has a central part. This is the central part. And this central part is known as nucleus. Okay. Nucleus and the remaining part. This is the atom. Atom has the central part, that is the nucleus. The central part of an atom is known as nucleus. The central part of an atom is known as nucleus. Okay, is known as nucleus. Now let us see the location of these three fundamental particles, means where protons are present, electrons are present, and neutrons are present. Okay, in the central part, that is in the nucleus, protons and neutrons are present. Protons and neutrons are present in the nucleus, and electrons are present at outside of the nucleus. At outside of the nucleus. I repeat, atom is spherical in shape, in which there is a central part that is known as nucleus, in which protons and neutrons are present, and electrons are at outside of the nucleus. Outside of the nucleus. That is the simple structure of an atom, right? I repeat. So atom is the central, atom is spherical in shape, and it has a central part that is known as nucleus, and electrons are present at outside of the nucleus, and at the nucleus protons and neutrons are present. Protons and neutrons are present, right? So please copy it, otherwise you can take the screenshot of it. Okay, before going to it, or before going to the next topic, let us have a small revision. Atom has three fundamental particles: proton having positive charge, electron with negative charge, neutron with no charge. Protons and neutrons, Pn, are present at the central part of the atom, which is known as nucleus, and electrons are at outside of the nucleus. Okay. Next, you can take the screenshot, otherwise you can pause the video and then write. Right. You see, in the central part of the atom, protons and neutrons are present. So protons and neutrons are combinedly known as nucleons. Suppose if you are in India, okay, if people are in India, then the peoples are called as Indians. Suppose if you are in Vijayawada, Vijayawadians. Suppose if you are in Guntur, we can say Gunturians. Now here, protons and neutrons are present in the nucleus. Therefore, protons and neutrons combinedly known as nucleons. Okay, nucleons. Protons and neutrons. Neutrons are combinedly known as nucleons. Combinedly known as nucleons. Okay, protons plus neutrons, nothing but nucleons. What are nucleons? Protons and neutrons. Why they are called nucleons? As they are present in the nucleus. Okay, next. Charge of the nucleus. Charge of the nucleus. Charge of the nucleus. So here in the nucleus, there are two subatomic particles, proton and neutron. So proton and neutron. What is the charge of proton? Positive. Charge of neutron? No charge. That is 0. Positive plus 0, positive. The charge of the nucleus is positive. The charge of the nucleus is positive because protons with protons with positive charge plus neutrons with no charge. So combinedly what you will get? Positive plus 0, positive. Okay, so the charge of the nucleus is positive. Okay, next point, you see, in any atom, if you take any atom, the number of protons is equal to number of electrons. Number of protons is equal to number of electrons. That means number of positive charges is equal to number of negative charges. Number of positive charges is equal to number of negative charges. If both positive and negative are same, then what is the resultant charge? 0. That is no charge. No charge. I repeat, if we take any atom that has same number of protons and same number of electrons. Protons means protons with positive charge, electron with negative charge. Same number of positive and same number of negative. So if we can combine these two of an atom, okay, 0 charge. 0 means no charge. No charge means neutral. Neutral. Okay, so atom is always neutral. Atom is always neutral. Always is that atom is always neutral because it contain equal number of protons having positive charge and electrons which have negative charge. Okay, I repeat, atom is always neutral because it contains equal number of protons and electrons. So protons positive charge, same number of positive and same number of negative. That is why atom is neutral. So atom is neutral. Atom is neutral. Let us take an example. Oxygen. Oxygen. Okay, if you take oxygen atom, here is the oxygen atom. It has the central part. It has 8 protons, 8 neutrons, and 8 electrons. 8 protons, 8 neutrons, and 8 electrons. If you take another example, nitrogen. Nitrogen. Okay, here nitrogen atom, central part, that's the nucleus. It has 7 protons, 7 neutrons, and 7 electrons. 7 protons, 7 neutrons, and 7 electrons. Now you take another example, fluorine. Fluorine. So here is the fluorine atom. Fluorine atom. It has a central part. It has a central part known as nucleus, in which there are 9 protons, 10 neutrons. 9 protons, 10 neutrons, and 9 electrons. 9 protons, 10 neutrons, and 9 electrons. Now, if we can see these elements or atoms, okay, atoms, in all these atoms, equal number of protons and electrons. 8 protons, 8 electrons. 7 protons, 7 electrons. 9 protons, 9 electrons. But when coming to the number of neutrons, they may be same or different. 8, 8, 8, 7 protons, 7 neutrons, 7 protons, 7 neutrons, same. Here 9 protons, 10 neutrons. Okay, so protons is equal to electrons. Okay, but protons and neutrons may or may not same. Protons and neutrons may or may not same. In general, the number of neutrons are more than protons. Okay, so I can write protons are less than or equal to neutrons. Protons is equal to neutrons or less than neutrons. So in any atom, number of protons is equal to electrons, Are protons equal to neutrons or less than? Less than neutrons. So in an atom, the number of protons and neutrons are same, or the number of neutrons are more than number of protons. Right? So this is all about protons, electrons, and neutrons. Right? Now let's move on to the next topic. Please take a screenshot or pause the video and then write. Now, let us have one more new word, that is element. That is element. Okay? The new term, that is element. Don't get confused with element. Element and atoms are more or less same. Element and atoms are more or less same. Right. Now, what is element? Element is a pure substance. Pure means which contain a same kind. Suppose in a class, if all students are boys, then the class is pure because same gender. Suppose if there are both boys and girls, okay, then I can say impure class because there are two types of genders. Similarly, here pure means same kind. So element consists of same kind of atoms. Elements consist of same kind of atoms. It contains, or it is a pure substance. It is a pure substance and it contain same kind of atoms. It is a pure substance and it contains same kind of atoms. Okay, let us understand it with examples. Let us take our friend oxygen. Oxygen is an element. Oxygen as an element. So here it contains only oxygen atoms. Contains only oxygen atoms. Suppose if you take gold is also pure substance. Sir, it is an element. Gold is the element. Okay, it contains gold atoms. Okay, oxygen contains oxygen atoms. Gold contains gold atoms. So in conclusion, what are there in elements? Atoms. Okay, in element, atoms are there. Suppose, let us say it is a gold. The color of gold is yellow. The gold symbol is AU. So in gold, okay, we can see only gold atoms. Only gold atoms. No silver atoms, no magnesium atoms, no oxygen atoms, right? So element contain only same kind of atoms. Okay. Suppose if you take oxygen, its symbol is O, contains oxygen atoms. So in oxygen, these two oxygens were binded, okay, as O2. As I said, oxygen gas, okay. So oxygen, 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 oxygen. So throughout the oxygen, we can see only oxygen, right? There's the difference. Here, gold and gold will also bind through a metallic bond, that is imaginary bond. Okay, we'll discuss later about bonds. Gold, so gold element has gold atoms, oxygen element has oxygen atoms. Clear? So element is a pure substance, it contains only one kind of atoms. Gold, gold atoms, right? Oxygen, oxygen. So pause the video and then write. Okay, otherwise you can take the screenshot. Right. Now let us have one more one more new term, that is compound. Compound. Okay, so in your lifetime you might have across different kind of compounds, like water. Water is a compound. Calcium oxide is a compound. Sodium chloride is a compound. Okay, baking soda is a compound. Now what is meant by compound? What is meant by compound? If you take a sugar as a compound, the sugar contains only sugar molecules. Sugar compound contains sugar molecules. If you take water as a compound, water is a compound. It contains only water molecules. Water molecules, H2O. Water molecules. No other type of molecules. No other type of molecules. So same kind of molecules. What is meant by molecule? Molecule is formed by the combination of atoms. Here hydrogen, hydrogen, oxygen. Okay. If a substance contains same kind of molecules, then the substance is said to be a compound. If a substance contains same kind of molecules, then that is said to be, okay, compound. So same kind means pure substance. It is a pure substance. It is a pure substance which contain same kind of molecules. Same kind of molecules. Okay, any substance which contains same kind of molecule, then the substance is said to be, okay, compound. Okay, I will write in the bracket, any substance which contain same kind of molecules, and the compound is said to be, compound. Sorry, then the substance is said to be compound. Okay, compound. Here is an example, water. Second example, NaCl, table salt. The formula is NaCl. Okay, table salt is a compound. Which contains only sodium chloride molecules. Sodium symbol is Na, and chlorine symbol is Cl. Okay, so water contains only water molecule. Sodium chloride, that is table salt, contain sodium chloride molecules. I hope you understood the difference between element and compound. In element, same kind of atoms, whereas in the compound, same kind of molecules. Okay, in element, same kind of atoms. In compound, same kind of molecules. I hope you understood the difference between element and compound. If you want, I will give one more different types of examples for elements and compounds. Please take the screenshot or pause it and then write. Let us see the difference between element and compound. Okay, let us see the difference between one more molecule, element and compound. Molecule, element and compound, right? Molecule is formed by the combination of atoms. It is formed by the combination of atoms. It is formed by the combination of atoms. Now we see, let us take an example. Okay, oxygen, symbol is O, oxygen. What is this? O2. Okay, this first example. Oxygen plus oxygen implies O2 molecule. Here is atom, this is molecule, right? In oxygen molecule, same kind of atoms. Second example, okay, we have taken in the previous example, water, hydrogen plus oxygen. Okay, you will get H2O. Okay, here molecule, atom. Okay, here different types of atoms. I can write here molecule with different kind of atoms. Okay, molecule with a different kind of atom. Here same kind of atoms. So molecule is formed by the combination of atoms. The molecule can be formed by the combination of same kind of atoms or different kind of atoms. If it is formed by the same kind of atoms, then the molecule is said to be, homo molecule. Or elemental molecule. I will explain why it is called elemental molecule. Okay, if you can see that previous concept, element contains same kind of atoms. Here in this substance contains same kind, therefore it is called elemental molecule. Okay, I repeat, oxygen atom, oxygen molecule in which all atoms are same, therefore it is called homo molecule, or also known as elemental molecule. Now here different kind of atoms. If molecule contains different kind of atom, that is called hetero molecule. This is also known as Okay, compound type, compound molecule. Okay, elemental molecule contains same kind of atoms. The compound molecule contains, okay, different kind of atoms or hetero molecules. Right. Now coming to the element, it contains same kind of atoms. Same kind of atoms. Okay, same kind of atoms. Now, example, oxygen. Oxygen contains oxygen atoms. Okay, we take gold atoms. Right? Yet present, okay, yet present, there are 118 elements. At present, there are 118 elements. That means in future, the number may go up. Okay, at present, there are 118. In future, the number may increase. That's not constant. So as you know that different element have different atoms. You see, oxygen atom, gold atom. Like this, there are 118. If there are 118 elements, then how many types of atoms will be there? 118 atoms. 118 type of atoms. 118 type of atoms. Oxygen atom, gold atom. Like that, 118 elements will have 118 type of atoms. Right? So students, tell me how many types of atoms? 118 type of atoms. Right? Now you see, coming to the compound. Okay, coming to the compound. It contain or it is composed of, same kind of molecules. Okay, same kind of molecules. Example, water. Example, water. Sugar. Okay, then limestone. Sorry, not limestone. Calcium carbonate. Baking soda. The difference between element and compound. Element contains same kind of atoms. Compound same kind of molecules. Okay, but here the molecule is composed of, okay, in the compound molecules composed of different kind of atoms. If molecule contains same kind of atom, that comes under element. Right? So at present there are 118 elements, means 118 type of atoms. Okay, I hope you understood the difference between molecule, element, compound. Homomolecule is an element, heteromolecule is a compound. So let us segregate, okay, species into elements and compounds. Please take the screenshot of it. Otherwise, you can pause the video and then write. Okay, now you see, is the question. Identify atoms, elements, and compounds from the following list. from the following list. Okay, atom means single species. Okay, one, okay, H. Second one, H2O. Third one, NaCl. Fourth one, O2. Fifth one, O3. Sixth one, CaCO3. Seventh one, Mg. Now let us segregate atoms. First one, seventh one. Then elements. Okay, here the elements are same kind. Fourth one, fifth one. Then compounds. Okay, here what else? Second one, third one, different types of atoms. Sixth one. Okay, so that's the way to segregate the atoms, elements, and compounds. Elements are also considered as atoms because element has atoms only. Okay, element has atoms, right? This is all about this lecture 2. Thank you very much. We'll come up with lecture 3.